A very good afternoon to all my audience, panel, and supervisor. My name is Tam Wichen from 4BKN Session 2 with project title Design and Development of On-the-Go Soil Fertility Measurement by using ATV. For the introduction, the human population has been growing day by day and the requirement of the food resources also increased. WHO has mentioned that in 2020, there are 820 million people in the world suffer in hunger. The World Food Programme are decided to end the hunger, and one of the solutions they have planned are promote the sustainable agriculture. However, there are some problems faced by the farmer and researcher during the agricultural activity, and the biggest problem are the variability in the farm. The variability in the farm can be categorized in two terms, which are the short-term and the long-term variability. The short-term variability changes between the season, and the long-term variability changes along the time step. Another problem faced in the agricultural activity is the waste of the fertilizer. The overuse of the fertilizer may cause the waste of fertilizer. The waste of fertilizer happens when too much of fertilizer used in the agricultural activity and the fertilizer does not absorb by the plant. And this will cause the soil pollution, water pollution, or acidic rain. The problem statement of my project is the soil fertility analysis. The traditional method of the soil property analysis is by using the laboratory analysis. This analysis taking a soil sampling per 1 to 3 hectare, and the result of analysis take 2 to 3 months to be obtained. The weakness of this analysis are the long time required, and it requires human energy to do the soil sampling, and the result is inaccurate since the soil variability change from time to time. The second problem statement of my project is the capability of the data collection. The farm management requires a big amount of data, and the large amount of sample need to be collected from different areas of the field. The proposed solution for the problem statement of this project are the real-time and on-the-go soil nutrient analysis system. The real-time and on-the-go soil nutrient analysis system able to help the farmer to analyze the concentration of the soil nutrient in the field in real time, and the result of the analysis can be obtained within 1 day. Next is the mobile platform and automated soil sampling system has been used to replace the human energy required in the soil sampling. Lastly, the monitoring and GPS fertility mapping has been used to help the farmer do the field management depending on the locational data. Next, we proceed to the methodology of my project. We start with the system design and component selection of my project. The mobile platform that I have selected are the ATV. The ATV are selected compared to the tractor that commonly used in the agricultural activity and a drone with the high technology. From the table, we can see that the stability of the ATV and a tractor is more stable compared to a drone due to their four-wheel design. And for the operation space, the ATV require medium size of operation space compared to a tractor that require large operation space. For the maintenance and services, ATV having a medium level of maintenance and services, and for the weight of the road carry, tractor able to carry the heaviest weight compared to a ATV and the drones. However, in this project, the soil sampling collector system that we have developed is in a medium size and a medium weight, which able to be carried by using the ATV. For the drones only able to carry the load with a light weight, so the drones are not suitable for the soil nutrient analysis task. For the sensor selected, we have selected the ISE sensor. From the table, we can see that the ISE sensor and the electrical conductivity sensor having a small size compared to the penetrologue sensor, and the ISE sensor are work with the principal iron selected. This is suitable for our objective due to the objective of our project is to analyze the concentration of iron content in the soil. The parameter measurement of the ISE sensor is the concentration of the micronutrient, nitrate, potassium, and phosphorus, and the weakness of the ISE sensor is the sensor can only done the measurement in the aqueous solution. For the electrical conductivity sensor is work with the working principle electrical conductivity. The parameter that can be measured by the electrical conductivity sensor are the soil nutrient electrical conductivity and the soil moisture. The weakness of the electrical conductivity sensor is the measurement of the soil nutrient will be affected by the soil moisture. For the penetrologue, we can see that the penetrologue having a big size compared to the other sensors, and the working principle of the penetrologue is by using the vertical breaking force of the soil. The parameter that can be measured by the penetrologue are the soil moisture, soil density, and the soil strength. The weakness of the penetrologue is the vertical breaking method will harm the root of the plant, since the penetrologue will take the soil sample in a depth of 1 to 3 meter. However, in this project, we just take the soil sample in a depth of about 20 cm. This is the system configuration of my project. At the input, we can see that the water and the soil will mix together by using the mixer. The data will be analyzed by using the ISE sensor. The soil nutrient data and the locational data will be sent to the Raspberry Pi and Arduino Uno controller, and the data will be saved in the SD card and displayed in a monitoring system like LCD, computer, laptop or handphone. After the data have been collected, the soil mixture will be poured back to the soil by using the soil collector actuator. For the soil sampling method, the soil sample will be collected with the depth of 20 cm and the sampling area is about 1 to 3 hectares. The distance between the sample are 10 meters, and the sampling method that we have used is the grid point sampling. The grid point sampling is a method that taking the sample in the middle of the sample area that we have designed. For the mechanical part installed on the ATV are the soil sample collector actuator, soil mixer and the water pump system. For the sensor and controller use are the ISE sensor used to analyze the soil nutrient, the Neo GPS device used to record the coordination data, and the Arduino Uno and Raspberry Pi Model 4 used as the controller. For the software used are Node-RED, Python, QGIS, and Arduino IDE. The Arduino IDE used to program the Neo GPS device, and the Node-RED 4 control the flow of the data collected by the ISE sensor and GPS, and the Python program used to activate the ISE sensor. After that, the QGIS was used to do the fertility mapping. For the sensor validation and system performance evaluation, the evaluation of the ISE sensor was done by using the non-concentration aqueous solution. The experiments are repeated in 3 times for each solution. The solution prepared are low concentration sodium nitrate, high concentration sodium nitrate, low concentrated potassium chloride, and high concentration potassium chloride. The method of the evaluation are by calculating the percentage of error of the sensor. Next, we proceed to the data analysis. The data analysis will be done in purpose to identify the relationship between the electrical conductivity of the soil with nitrate and potassium nutrient. The analysis will be done by comparing the soil nutrient data collected by the ISE sensor with the EC sensor by using the linear regression method. Next, we proceed to the system setup. Figure shows the system setup of my system. The LCD display was connected with the Raspberry Pi controller, and the new GPS device is connected with the Arduino Uno board. Lastly, the ISE sensor and Arduino Uno board was connected to the Raspberry Pi by using the serial port. Now we proceed to the result and discussion part. This is the table of the result of the percentage of error calculation of the ISE sensor. From the result, we know that the lowest percentage of error of the sensor are 0.09% and the highest of the result are 9.51%. From the result, we can see that there are not percentage error that they are more than 10%, which means the error calculation of the ISE sensor is not more than 1 ng per L. This error can be ignored since the analysis results are based on the whole number. This is the result of the 42 soil sample data collected from the palm oil field, UITN Jasin. The nutrient concentration of nitrate and potassium are recorded in CSV file. From the figure, we can see that the timestamp are recorded and the GPS coordination can be recorded in terms of latitude and longitude, and the concentration of the nitrate and potassium are recorded in unit of ng per L. Next, we proceed to the result of the linear regression analysis. The figure at the right shows the linear regression analysis graph of the potassium and nitrate versus the electrical conductivity. From the result, we can see that the R-square value of the potassium are 0.3168, the nitrate are 0.0243, and the EC are 0.0035. From this result, we can make a conclusion that the electrical conductivity of the soil are not related with the potassium and nitrate nutrients. The electrical conductivity is an indirect method used to analyze the amount of salt content in the soil but not the soil nutrient, and the result of the electrical conductivity analysis will be affected by the soil's moisture. Next is the user interface of my project. From the figure, we can see that the user interface content of the coordination, soil nutrient concentration, and the battery level of the sensor. Now we proceed with the result of the fertility mapping. Figure below shows that the potassium and the nitrate soil nutrient fertility mapping that formed by using 42 soil sample collected at the palm oil field UITN Jasim. The figure at the left side is the potassium fertility mapping, and the figure at the right side is the nitrate fertility mapping. The legend has been added to categorize the level of the soil's nutrient, and this can help the farmer to do the fertilizing treatment more easily. Each color of the legend represents the concentration level of the nutrient contained in the soil. For the red color means that the lack of the nutrient. Yellow color is the median level of the nutrient. Green color is the nutrient level is good and enough. The blue color is the overuse of the nutrient. From the left figure, you can see that there are some combination of color with yellow, green and red. Means that the farmer need to apply the fertilizer. Focus on the red color area. Next, for the nitrate fertility mapping. Figure shows that all of the area are red color, means that the soil of this area lack of the nitrate nutrient. The farmer need to provide the nitrate fertilizer to all of the area on the coordinate. Next, we proceed to the project demonstration.
Now, I would like to demonstrate the operational function of the sensory prototype of my project. As we can see, this is a LCD display connected with the Raspberry Pi controller, and the new GPS device was connected with the Raspberry Pi controller also, and these two are the ISE sensor used to analyze the soil nutrient. To analyze the soil nutrient, we need to mix the soil with the water, and then we need to immerse our ISE sensor into the liquid solution that we have made with soil. After the ISE sensor has immersed into the soil liquid solution, we can start our soil nutrient analysis by running our program in the Python. Next, I will proceed to the software operation of my project. We can control our system through the laptop by using the VNC viewer, and this can help us to monitoring our system through the different displays.
This is the Python program that we have used to start our soil nutrient analysis test. The sample that we have taken is 20 samples. To start our soil nutrient analysis, we need to click the run button and select the sensor we need. The sensors selected are depend on the device, and we select 2 for the nitrate and 6 for the potassium. After that, we select the period for each sample take. We select 1 second for each second take, and we can see that this is the result taken by the sensor. This is the flow of the node rate, and from here we can see that this is the interface that real-time monitoring the sample collected. After finish the sampling, we can see that the program will quit immediately, and the sample collected will set as a CSV file. This is the sample of data that we can get from the system. This is the sample from UIT and Jasin. The timestamp, coordination, and soil nutrient are recorded and saved as the CSV file. From this CSV file, we can form a soil fertility mapping. The fertility mapping can be formed by using the data collected. The farmer can view the property of the soil sample by opening the attribute table, and by using this mapping, farmer can easily understand which location are lagging of the soil nutrient nitrate. So, farmer can providing the fertilizer depend on the fertility mapping. For the conclusion of the project, we can say that all objectives of this project has been achieved. The automated soil sampling system has been developed by using the ATV, and the system developed able to analyze the soil nutrient nitrate and potassium content in the soil by using the ISE sensor. The fertility mapping also has been created by combining the GPS device and the QGIS software. Farmer able to do the fertilizing depend on the fertility mapping that have been created by the system, and this can minimize the waste of the fertilizer in agricultural activity. For the improvement of the system can be improved by adding the soil moisture analysis system or adding the automated watering system and fertilizing system to help the farmer to do the agricultural activity automatically. That's all from me. Thank you.